When a question says solve the following triangles, like this one says solve you have to find everything. So let's start off by maybe finding x here. Okay, we're going to start off by finding that x on the bottom. So we're going to label the triangle in a different sides, and we're going to find x first. So we will use, we're going to label it, so that's the opposite. Across the hypotenuse, and beside it is the adjacent. So we've got, there are two ratios that we're going to use, is adjacent and opposite. So adjacent and opposite, adjacent and opposite, adjacent and opposite, adjacent, tan of theta. Last one here, tan of theta. So over here, tan of theta is opposite over adjacent. So tan of our angle, so let's take a look what our angle is. 37, opposite, 15 over x. Now we're going to figure out x. This is the way we did it the other day. So I'm going to just cross multiply here. I'm going to cross multiply. So it's x tan of 37 is 15. And I'm going to divide by tan of 37. And I'm going to divide by tan of 37. Now there's the other way to do it where you find this as a number first. And then you divide by that number. But let's see what x turns out to be. So 15 divided by tan 37. So we'll go to my calculator here. 15 divided by tan of 37. So tan 37. Ooh, let's do that again. 15 divided by tan 37. Close the bracket and make sure to hit enter. 19.9. Let's see what the units are. 19.9 what? Meters. So 19.9 meters. Now, we have to find the hypotenuse here. Now, you could use Pythagorean theorem because you got 19.9 meters. You can go 19.9 meters squared plus 15 squared equals c squared, or c squared equals a squared plus b squared. But I'm just going to apply a second trig ratio. So I'm going to do a second trig ratio. I'm going to call this one y. So I'm going to pick this one here and I'm going to call it y. And I'm going to use these two trig ratios. So let's use the little dash one. I'm going to use, let's try that again. I'm surprised there goes this one. And I'm going to use the opposite. So this time I'm going to use hypotenuse and opposite, or opposite and hypotenuse. So in this case, opposite and hypotenuse, opposite sine. So I'm going to use sine of 37 to find the other one. So way down here, I'm going to use sine of 37, or sine of the angle. Neat. Let's go back and write a little bit better. Sine, I'll write it here. Sine of the angle is opposite over hypotenuse. So let's see, the angle is 37. So sine of 37 is way up, sine of 37. So sine of the opposite is 15 over y. So now we have 15 over y. Just double check. 15 over here. So opposite over y. So we'll go over here. Sine is 15 over y. I'll do this one the other way. I'm going to actually find sine. I'll use this calculator. So I'll go sine. Oh, it's here. Oh, first we got to put the numbers. This one's always the other way around. So first we put 37. We go here and we pick sine. Gives us decimal, so I'll write it. 0.6018 equals 15 over y. 15 over y, we put it over 1, we cross multiply, so we get 0.06018y equaling to 15, and then we divide by 0.6018, and divide this one by 0.6018. Bring that a little bit lower. 15 divided by, we're here, 15 divided by 0.6018, and then you get 24.9. So y is 24.9, and I believe meters. So far we found y. Up here we found x, and we have everything. So x is 19.9. This is the longest side, yes. Now we still don't know this angle. We just don't know that angle up here, this angle up here. We'll call it theta. Well, all the angles in the triangle add up to 180. So 180, okay, minus 90, minus 37. So if you take and you subtract all those, you can figure out what theta is, because they all add up to 180. So if you subtract the two, you know, if you subtract 90 and 37, you can figure it out. That's like 90 subtract 37, and 90 subtract 37, 53 degrees. So if I were to redo this triangle, so if I redraw it with all the information, that's what you do when I solved it. I'll redraw it on the next, another page. So we'll add another page, insert a blank page, and we'll redraw that exact triangle, put all the information on. So we got to theta 37, 90, 15. So we've got this 90, got 37 degrees. Let's go back. We know that that's 15 meters. We know our other angle is 53 degrees. So we'll put it here. This angle in here is 53 degrees. And the last two lengths, let's go see what they are. One length is 19.9, and the hypotenuse is 24.9, 19.9, and 24.9. So we found all the sides and all the angles of this triangle. We've solved it. We know all the sides and all the angles, and that's what it means to solve a triangle.